Hello everyone, dear friends, my name is Fred, and in this video, I'll show you how to create a more complex stylized water material in Unreal Engine 5. Our water will have customizable foam that can interact with other objects. In the last video, you really asked me to record a second part, and I'm very grateful for your engagement, so please like and subscribe to the channel if you haven't already. In this video, I will be using Unreal Engine version 5.4 and recommend using it to avoid various errors. If you encounter any difficulties, join our Starlighted Craft Discord server in the help section, where we can assist each other. For this video, I've prepared a small pond and added a simple plane where we'll test our future water. I've also taken a rock so that during the process, we can adjust the foam for our future water. Let's start creating the material, and for this, I'll simply create a new material and name it Stylized Water number 2. Now, let's open our material, and before we start, I want to change the blend mode of the material to translucent. And also change the lighting mode to translucent because we will be creating a water material. I want to immediately add 3 constants for metal, roughness, and specular. Just press the Control key and the number 1, and connect the constants to the channels. We convert the roughness constant into a parameter so that we can control the values and assign it a name for easier navigation in the material. Now I want to create a color system for our water, and I simply add a parameter, which I duplicate several times. The first parameter will be responsible for the water color, and the second for the edge color. I immediately assign names to our parameters so that it's easier to work with the material later. To mix these colors, we add a lerp node and insert the color parameter into channels A and B. This will be a linear interpolation between A and B based on alpha. To achieve smooth color blending, add a depth fade node and connect it to the alpha channel. But to control the intensity later, simply add a constant and convert it into a parameter. I'll name it water depth to avoid confusion in the material and set the value to 300. I simply insert the resulting color system into the base color channel. Let's add color to our water. I want the overall color to be dark, and the water edges a bit lighter. You can choose any colors you like. It doesn't matter. On the sphere to the left, you can already see how the water depth works, and we get a smooth gradient provided by the depth fade node. Let's start creating the wave system. First, I add a texture node. Next, we need a panner node. It is responsible for animating the texture along the U and versus coordinates. I hope you remember this from the first video about creating simple water. I also add multiply using the letter M and left mouse click. And let's add a texture coordinate node. It outputs the UV texture coordinates as a 2-channel vector value, allowing materials to use different UV channels, create tiling, and work with UV coordinates in other ways. I also want to add parameters to the multiply and panner speed so we can control the deformation speed of our texture. I set the speed value to 0.03 for calm wave animation, and the distortion value to about 30 so the texture doesn't deform too much. You can set your own values or change them later in the material instance. Don't forget to name our parameters, and now I duplicate our node one more time and connect point A in the multiply to the texture coordinates. In the duplicated node, I go to the deformation parameter and change the name to avoid confusion. Let's also set the default value to 10 so our textures have different tiling and mix more interestingly. I also change the name in the speed parameter but leave the value the same. In this video, I will be using 2 textures. These are waves and a normal map for water. As usual, I'll leave an archive with these textures on my Discord server in the tools section. Join our open community via the link in the description. Now we need to add the wave map to 2 texture sample nodes. This can be done by drag and drop or by selecting the required texture in the texture section. Now let's drag the normal map into our material, and I'm going to blend this map with our wave texture. For this, I add a multiply node, which needs to be inserted into the green channel of the wave texture. And we add an add texture, which I connect with the normal map. Essentially, I want to blend the normal map so that it integrates into the main pattern. Let's add another panner node for animating our normal map and another multiply. I insert the panner into channel B, and we connect the multiply with the coordinate channel. To enable blending in our node, I connect the texture coordinates with our new multiply. Using the middle mouse button, I add a point called reroute, which allows you to redirect the wire without affecting the data flow. This is a kind of visual optimization of the material aimed at convenience. In the B multiply channel, I add a constant, which I convert into a parameter. It will be responsible for the size of the normal map, so let's also give it a clear naming. Let's also reduce the value in multiply to 0.5, which is between the normal map and the texture. Now we need to add another append node to connect the speed parameter for our panner. I add constants to channels A and B, but I only convert the upper one into a parameter. Essentially, the lower constant will remain the same, and we will be able to control the upper constant, so I immediately give it a clear naming. Overall, our wave node is ready, so I want to shift it a little to have some free space. Let's refine it a bit now so that our normal map has transparency and blends more beautifully with the other textures. I add a vector 3 constant and set the blue color to maximum in the settings. Essentially, just enter the value 1 in channel B. We combine our normal map and color in a linear interpolation. And in the alpha channel, we add a constant, which we also convert into a parameter. It will be responsible for the transparency of the normal map, so I also give it a clear naming to avoid confusion in the material. Let's connect the lerp with our main node and save our material. It's time to see what we've got. At first glance, it looks like artifacts. In fact, these are very strange results. It looks like some kind of error because the normal map should work differently and give a softer result. Off-screen, I couldn't understand what was happening with the material for a long time, but in the end, restarting Unreal helped me. Apparently, I just forgot to compile the shader initially, although it's very strange because a regular save automatically calculates the material. In any case, the problem is solved, and I hope this doesn't happen to you. Now let me show you how the normal map should look correctly. Notice that now it displays differently and looks more voluminous. At the moment, we have written a system that kind of deforms the normal map using the red wave texture. This results in more unusual water behavior, which we can adjust in the material instance using convenient parameters. But this is just an intermediate stage, and I won't focus on it for now. Let's return to our material and start writing the foam, which will be generated along the edges of our water. First, I add a world position node. Essentially, these are just world coordinates. And now we add another function, distance surface, which is responsible for the distance of objects from the surface. I connect it to world position in the XYZ channel, thereby setting the distance value along 3 axes. Let's add a division and create a constant, which we will convert into a parameter. This will essentially be our shorelines, so you can give a clear naming for this parameter. Personally, I'll just call it shoreline. Next, I add a 1- node, which, simply put, inverts the value in the opposite direction. Now I need an addition node, which I connect 1 to channel A. In channel B, I insert multiplication and duplicate this system once more. It will be needed later to connect it to our wave system, so that the coastal waves can deform. In channel B of the first multiply, I set the value to 2, and in the second multiply, also in channel B, let's set the value to 3. Let's add another multiply and a saturate node. It is responsible for clipping values, leaving a range from 0 to 1. Now we have created a line system that is generated along the edges of objects that are in the water. Now let's create foam for the edges of our water. I add a division node and connect it to the distance surface function. Now let's create a parameter, which I call coastal foam. I set the parameter value to 60 and connect it to the divide node in channel B. This parameter will turn our lines into a semblance of foam through stretching. Now I add a 1 node and connect it to our divide. Now we add an addition node and a multiply, into which we insert the time value. Essentially, we have created an animation for our foam and coastline. Later, when we connect the coastline system to the wave system, the time node will refer to the pan value, and thus we will get animation. To control the speed of the animation, I add another parameter, which I call coastal speed. Let's set a small value so the animation is slow. I set the value to 0.3. Let's create a similar system as we did for our lines. This is an addition node and a multiply, which I duplicate once more. Later, we will also connect the foam to the wave system so that it deforms beautifully. In the values of channel B of the first multiply, I set it to 0.5, and in the values of B of the second multiply, I set it to 1.5. Now I add another multiply and create a parameter, which I call line. Let's set the value to 1.5. This parameter will be responsible for generating the number of lines that are near the water foam. Now I add a sign and connect another addition node to it, in which I also add a constant that needs to be converted into a parameter. I call it thickness. This parameter will be responsible for the transparency of the lines, so we can remove or add lines as you wish. To make this work as needed, I add a clamp function in an addition node, and connect it to the 1 node. Let's create a reroute point so our nodes look nice, and in channel B of the addition node, add multiply. I also add another addition node, which I connect to the saturate function. And overall, our system for the coastline and foam is ready. Now I want to move our node a little higher so we can connect it to our wave system. Because right now these are just straight lines, which will later blend with our wave texture and look even better. Now I connect the first multiply of the coastline to the green channel of the first wave texture, and the second multiply of the coastline to the green channel of the second wave texture, which mixes with the normal map. I want to make the direction of these lines clearer so you can see where these wires go. So I add several reroute points to them and try to align the direction. You don't have to do this, it's just for visual order. Now let's connect our foam to the first texture. For this, I connect the green channel of the texture and the first multiply of the foam. And I do the same with the second multiply, only I connect it to the lower texture. The multiply that comes from the clamp system, I also insert into the green channel. I tidy up the material a bit to make it easier for us to navigate. I just shift the color system a bit so we have more free space. Let's add another multiply to the clamp, in which I set the values to 2. I add a saturate function to limit the range of values from 0 to 1. And I insert the wire into the add node, which comes from our line system. This way, we close our foam and line system. Overall, the main material system is ready. And if you're creating this material with me, let me show you the complete system so you can check for similarities. Okay, now I add linear interpolation, and in the alpha channel, I insert the source from our system with lines and water foam. And in channel A, I bring in our color system, and now we insert this wire into the base color channel. As a result, we have created a wave system with a normal map, a color system with a gradient along the water's edges, and developed a system with shorelines and foam that deforms and blends with wave textures. I hope you understand the basic logic a little, and now let's save our material. Don't forget to compile it to avoid various bugs and errors, as I experienced earlier. And let's see what we have achieved so far. We open our material instance and first activate the new parameters we added. Now we can change the intensity of the foam along the water's edges, adjust the width of the shoreline, and change their speed. The first deformation parameter interacts with our foam and lines, while the second deformation parameter responds to our waves. The line parameter is responsible for the number of generated lines, and with the new thickness parameter, you can adjust the intensity of the line appearance. As you can see, foam lines form from all elements that are in the water, and this is a pretty cool effect that makes this water more stylized. But we're not done yet, and we need to refine the transparency system. Let's return to our material and continue. I want to create a transparency system for our water. First, I add a deep fade node. From the beginning of the video, you already know what it does. Essentially, we will have transparency for the center of the water and the shoreline so that we can create a semblance of depth. I add a reroute point in the center of the wire that comes from our main system with waves and foam and connects to the color system. Let's add a parameter to the fade distance value and set it to 2. Now I create linear interpolation and connect channel A with the deep fade node, and in the alpha channel, we lead the wire from our reroute point. I add a clamp node, which limits the value between two variables, minimum and maximum. Now create two constants. The first constant has a value of 0.5 and goes to the minimum value, and the second constant has a value of 1 and goes to the maximum value. Let's convert these constants into a parameter and assign them appropriate naming. When everything is ready, just connect our clamp node to the opacity channel. Now let's refine the water reflection. And I add a Fresnel node for this, which I connect to our normal map. This node allows us to get a reflection on our water based on our normal map. Add linear interpolation and connect Fresnel to the alpha channel. In channel A of our lerp, I set the value to 1.5. Now we need to connect the lerp to the refraction channel, but as you can see, this channel is currently inactive. To fix this, I select our main node and go to the settings on the left. We need to find the refraction tab and change the method to index refraction. Now our light refraction parameters should work stably. Let's save our material and go check what we have achieved. I open our material instance and activate the newly added parameters. These are fade distance, opacity min, and max. The first parameter, fade distance, creates a semblance of water density, and you can create various effects to make the water's edges more transparent and the center denser. The opacity parameter is responsible for the overall transparency of the water. With it, you can make your water denser or, conversely, crystal clear. To make the waves less contrasting, we have a separate normal opacity parameter. To achieve the desired result, I recommend combining the adjustment of these parameters because they are interconnected and adjusting the water comprehensively. Let's return to our material and make the final adjustment. First, I want to convert our specular constant into a parameter and set it to 0.2. Now let's create a glow system for our shorelines. To do this, I add a multiply node, insert a wire from our reroute point of the entire system, and connect the output to the emissive channel of our main node. To control the value, we simply add a constant, which I convert into a parameter and name it emissive. I set the parameter value to 0.2. Congratulations, our stylized water material is ready. We just need to optimize the hierarchy of our parameters so they are conveniently displayed in our material instance. I'll show you how to do this, but first, I want to mention that off-camera, I slightly refined this material and added caustics to it. Caustics, simply put, are the reflections of sunlight off the water. I think you've often seen this effect in crystal clear water, like in a pool or on wild beaches. If you want to enhance your water and add this effect, you can find an additional video on my Boosty via the link in the description. It will be available to VIP level subscribers in both English and Russian. If you're not particularly interested in my content, I'll make a one-time payment option for this video. The caustics system isn't very complicated, and your material will have several parameters for its adjustment. You can bend the caustics using the normal map, increase the scale of the caustics map from below or above, and adjust the speed of the caustics using the green channel. All the links can be found in the description of this video. Now let's get back to refining our water. As you can see, our material instance currently looks quite inconvenient, and all the parameters are mixed together, making the material settings unclear and awkward. To fix this, we need to distribute our parameters into categories. I select a parameter and assign a group name, and I insert the value 1. Then I go through all the necessary parameters and select this group, in my case, it's foam, and I also assign numbers in the category. The numbers serve a hierarchical function, allowing us to place more important parameters slightly higher and secondary ones lower. I deliberately zoomed out our system so you can clearly see the entire system of our foam and shorelines. It contains 5 parameters, which I place in the foam category and set the hierarchy. Now let's move a bit lower. This is the normal system. I select the first active parameter and assign it a new group, which I call normals. In total, our system has 6 active parameters, which I assign to our new normals group and assign numbers from 1 to 6 to each parameter. You can arrange your hierarchy as you see fit, so it's easier for you to understand and work with your material. While I'm distributing our parameters into groups and setting the hierarchy, I want to ask you to like this video and leave a comment. This is really important to me because such simple actions are our connection with you. Any activity on your part lets me know that you're interested in this kind of content and motivates me to record new videos for you. And if you're here for the first time, be sure to subscribe to the channel and hit the bell so you don't miss new content. Let's find the water transparency system and also add 3 parameters to the group. I'll simply name this group water. And I'll also distribute the hierarchy among the parameters to better navigate the material. The fade distance parameter will be at the top, with the opacity min and max parameters in second and third place. Okay, we've finished the visual optimization, and let's take a look at our final result. I open the material instance in our material. I want to show how the hierarchy of our parameters works. The numbers we arranged in order in each group now appear in the same order in our material instance. Let's activate our new glow parameter, and as you can see, with it, we can add a glow to our shorelines. If you activate the specular parameter, you can notice that it slightly highlights the inner glow of the water. Our material is ready, and now you can make more precise adjustments to achieve the visual effect you need. Objects interacting with the water also have dynamic foam and lines. I have a proposal for you. I can record a new video for you about creating even more complex stylized water, which will have even more subtle settings related to light refraction, shadows, dynamic stylized lines, and much more. This water will be created using a game pipeline that is used in games and has a more semi-realistic look, similar to the water in the game Wayfinder. All I ask from you is to gather 1,000 likes on this video. I know you can do it because in the last video you easily surpassed the 200 likes mark. And honestly, I wasn't ready for that, so this video was released with a big delay. So let's do it, and I'll immediately start recording this major video. On this wonderful note, I'll say goodbye to you. I hope this video was helpful to you. Don't forget about the additional video on Boosty if you want to improve your water material. And if you have any questions or problems, you can ask them on our Discord server in the help section and help each other out. I remind you that I created this material in Unreal Engine version 5.5.4, and this version is more stable for writing this material. And if you're here for the first time, be sure to subscribe to the channel, like this video, and hit the bell so you don't miss new stylized content in the world of game development. This was Fred with you, wishing you creative success. See you soon.